Now on this video we will be taking a look at a very interesting DDR5 memory kit from Predator Storage. Now Acer is actually going pretty hard with high performance DDR5 memory kits on this generation under their Predator branding. So Predator Storage is kind of their high performance gaming branding, but it's technically owned by Acer. This is probably the first time I'm trying any memory from Acer. I do remember seeing some very basic memory sticks from Acer in the past, but they were usually just some very basic like DDR3 memory sticks without any heatsinks and so on. So it will be very interesting to see what kind of memory can they actually bring out to the market. So anyways, this is the Predator Storage Hermes DDR5 RGB, and the spec is 32 gigabytes, so 2x16, 6800 mega transfers per second, CAS 32. So that's already a pretty reliable answer that this memory does use Hynix A-Die memory IC. You can't really produce 6800 CAS 32 in a reliable way from manufacturer's point of view with Hynix M-Die. So 6800 CAS 32 is already a very reliable option if you really want Hynix A-Die. When I looked on their website, the frequency range is from 6800 all the way up to DDR5 8000 for the Hermes series. Hermes isn't the only model they are bringing out the market. There were some other ones as well, but this is the one I got for the actual test for this video. So I'm very interested to see what kind of numbers we will see when we actually start to overclock this memory kit. So I'm not that much interested in the default specs. I'm mostly interested in what kind of frequencies can we reach even on ambient cooling for test use cases like Geekbench 3 AIDA64, and what's the maximum daily configuration tested in HCI Memtest. This far I've had the best result with the Hynix Green OEM and some very highly selected G-Skill Trident Z5 for daily somewhere around 8000 to 8200 with realistic voltage, and test runs at somewhere around 8600. That's like CAS 35 or 36, something like this. But anyways, so let's take a very brief look at the kit itself first, unbox the packaging, and then I'll start doing the actual tests and we'll wrap the video up with the capture card footage. But anyways, so the heatsink design already looks pretty interesting out of the box. So I'm sure they have some very nice photos of these sticks on their website, but let's actually take a look at the backside first. So some disclaimers, but let's take a look at the features first. So high efficiency aluminum heatsink, supports Intel XMP 3.0, supports Intel and AMD motherboards, selected IC, ensure durability and reliability. So it's possible they actually screen the individual ICs first before they put them on the actual memory sticks PCB, and even afterwards they might still bin the actual sticks for those given frequencies. So I don't really know how each memory manufacturer actually produces their memory kits, but it's possible that some don't really screen the individual ICs. They just put the ICs, like random ICs, on the memory sticks and then just bin the actual memory sticks. That's not really something I really know a lot in depth. But anyways, so on-die ECC technology, RGB sync, supports Asus Aura Sync, MSI Mystic, whatever, or Light Sync. So that's RGB stuff, I guess. Polychrome sync software for lighting effects. Okay, lifetime warranty, made in China. They don't actually have the spec fully mentioned on the packaging like CAS 32, but it's already mentioned on the website, and it should be mentioned on the sticks themselves. So let's open up the packaging. So those are the sticks themselves. The heatsink design looks at least pretty cool to my eye. Oh, the full spec is over there. 6800 CAS 32 45 45 108, and that should be 1.4 volts. So that's kind of normal, not 1.45, it's 1.4 volts. I think the highest frequency kits will have 1.45 as the default suggested memory voltage. So that's pretty normal. Let's get the sticks out. Oh, they do actually have some cooling accessories included. Actually, it's pretty rare nowadays to see any kind of fan accessory for the memory sticks. So they have some bracket, a fan, and installation screws, so I guess you can hook this small fan on top of the actual memory sticks to provide some additional cooling. My own experience with Hynix A-Die this far and DDR5 is that they do actually warm up pretty fast when you really stress them a lot. Like full capacity HCI Memtest, you can easily see temperatures of like 50 degrees Celsius, even 70 and onwards if you don't have active cooling over the memory sticks. So it's actually pretty recommended to have at least some kind of heat sinks on your memory and pretty decent airflow over the memory sticks if you are really pushing your memory hard, because I would at least like to have some adequate airflow over the memories if you really stress them a lot, like large capacities being used at relatively high voltage, relatively high frequency and so on. So that's something I would like to at least tell you about. So please be aware of the temperatures of these Hynix A-Die memory sticks. But yeah, these are the sticks themselves. So they do have some warranty information inside and some fan assembly diagram. At least it looked pretty difficult at first glance, like how do you actually install the fan on top of the memory sticks. So the heatsink design is pretty tall. It seems they have some RGB lighting over here at the top part of the memory stick, but at first glance, at least in my opinion, this is probably the best looking DDR5 like memory kit that I've seen this far. So definitely will look good in any kind of system, no matter which motherboard model you choose, whether it's a dark KINGPIN, Apex, Tachyon, whatever. So should fit every kind of rig pretty nicely. But yeah, so let's move on to the most important part of this video. So I will hook these memories in the EVGA Z790 dark KINGPIN, and I will select the best IMC first, because I have 5 individual CPUs and you are actually very IMC limited with these high performance DDR5 memory kits if you really have particularly good memory kit that can go very high, even on ambient cooling. So many CPUs even fail, like 8500 to 8600 on ambient cooling. So if you want to go for the really high frequencies, you really need a golden IMC. So I will test the best IMC first, and then we can actually start looking at the actual results from these memory sticks. But yeah, without further ado, I'll get the system going and let's move on to the actual results. And okay, that's how the Acer, Predator, Hermes DDR5 sticks actually look like when they are installed on the EVGA Z790 dark KINGPIN. Tall heatsink design with those good looking RGB lights on top. But now let's see how they actually perform. And okay, so the highest memory frequency I managed to achieve like ever on ambient based cooling was like 8600 with the Hynix Green OEM memory sticks. Now these sticks from Predator or Acer, they could easily post and boot 8600 with my best IMC. I briefly tested 5 individual CPUs with this memory kit, and 3 CPUs I really had hard time to even post 8600 and some couldn't post it at all. The engineering sample CPU I used a lot this far, which also did like 9200 and 9250 on LN2 with the Hynix Green OEM sticks, also on LN2. That one can run 8600, but quite barely. This CPU, which I used for the G-Skill World Cup competition during Computex, seems to have the best IMC for like performance-oriented tests. Now I'm using roughly the same like timing table, so DDR5 8600, CAS 34, 47, 47, 42, command rate 2. So let's try to run Geekbench 3. I usually like to run like Geekbench 3 and maybe AIDA64 for like performance testing, and for like 24/7 operation I like to use the HCI Memtest, because you have to test the entire capacity of the memory you have installed in your system to really know if it's stable for like 24/7 operation. So actually I want to open core temp. So of course if we are on the edge it might not like pass every single time, but let's see. So it's running. Currently the maximum temperatures are somewhere in like between 65 and 70. Now when it hits AVX it will go higher. So it was like a bit over 70, Now we should have a score. So around 15,800. Of course, we could improve the score by tightening some of the main timings like the TRP and maybe TRAS, but I really like to just know what kind of frequencies we can achieve with pretty good timing table overall and like good main timings. So when I look at the SPD tab, this Predator kit doesn't really have any info over here. It could be because it's still not fully added to the CPU-Z, I don't know, but it's SK Hynix and the part number, it seems to be correct. So I'll open up rest of the CPU-Z screens, and the interesting part about this run is that the memory voltage is only at 1.55. When I tested all of my G-Skill sticks, the Hynix Screen OEM, the real memory voltage for these high frequency runs was always around 1.65. So this is definitely, based on these fast numbers, this is already the best DDR5 Hynix A-Die kit that I've ever tested this far. So pretty interesting numbers overall, if you ask me. So let's put that over there. And now let's open up hardware info for the voltage. So here's the voltage, 1.55, 1.55. So definitely not that bad if you ask me. And now for the sub timings, let's open up ELID X1 so you can see 34, 47, 47, 42. TRFC could definitely go a bit lower at 8600. It's very heavily tied to the frequency you are running. Maximum on the refresh interval and the third timings are nearly as tight as they can really go, pretty much. So let's put that over there. And where's the motherboard CPU-Z? It's over there. So let's save this. And now let's try to run a bit higher. I think 8800 is probably going to be out of reach because it needs so good IMC. But we can try a bit higher, like I'm sure 8733 could be doable. Maybe 8750. So let's give it a go. Let's see what happens. So let's try. So this is around 8733. Of course, the CPU frequency isn't as high what it could be, but I'm not using the best possible cooling on the CPU at the moment, so I want to keep it at reasonable temperatures, etc. So I really want to see what's the maximum frequency I can pass with this timing table with this particular kit. Okay, so 8733 still passing, so pretty interesting. I really want to see how much does the score improve just from this 133 mega transfer per second increase on the memory frequency. So 15,950, maybe 16,000 on a good run. So now I'll try. The CPU frequency does help a little bit with the memory score as well. So let's try. Okay, still passing with just one attempt. I set the actual process to real time, see if it helps with the score at all. Okay, so 16,005. Score could be a little bit better, but it's still pretty okay. So let's save this again, because this is probably, as I was already briefly checking this kit, this seems to be the best figure I can actually reach on ambient based cooling. So a bit over 16,000, it's definitely alright for ambient cooled result. So the highest scores in Geekbench 3 have been a bit over 18,000 when you run the frequency at like 9200 plus with both the CPU and the memory on LN2. So let's open up the voltage once again. So there's the voltage. But really, when we are approaching 8800 with only 1.55 volts on the memory, that's definitely a good result if you ask me. So let's save this. And we can still give it a go, like really want to see 8800. So let's, I'm not actually sure. I think 8800 should be. So that's 8800, 5219 or 5220 on the CPU. But I think this is not gonna pass. So yeah, so this already starts failing. So I think that 8750 will be the highest frequency for now, but again I'm sure it is just IMC limit because I couldn't get anywhere near this level with my other CPUs. So I'll try a few more attempts, but if it doesn't want to run, I'll go back to 8750 and let's run like AIDA64 to see what are the actual bandwidth figures for that configuration. Okay, so 8800 is definitely out of reach, so I'm sure it is an IMC limit because, for example, raising the memory voltage, it doesn't really help at all. But now, even with same memory voltage of 1.55, I managed to tighten some of the main timings by quite a bit. So still at 8755, but at 34, 47, 42, 36. And when you lower especially the TRAS, the bank cycle time goes down a lot as well. But I don't really know how this timing works on these Intel platforms. This used to be like an AMD only memory timing. So this result is definitely alright for an air-cooled system and for 1.55 volt memory voltage. So let's save this and then let's try to run AIDA64 and wrap this whole thing up, and after that I will test the daily overclocking capability of the kit I'm using at the moment. So just need a motherboard plus memory, CPU Z only, and let's open up hardware info and ELEAD X1 for the sub timings. So hardware info. So here are the memory voltages, so still at 1.55, VDD plus VDDQ, and here are the sub timings. So the sub timings, they are pretty much the same. I only tightened the TRFC plus this one a little bit, so 595 and 505, but they can't really go any lower at this given memory frequency pretty much. Okay, so that's our best run in Geekbench 3 at, on ambient cooling, I mean. So now let's try to run AIDA64 on this generation, and DDR5 AIDA64 is actually harder than ever before, so sometimes it might even fail even if you can pass, let's say, Geekbench 3. But let's see what happens. At least the latency value should come down with those lowered timings. Let's see what happens. Read is 138.77. I actually got a bit better result on some of my earlier attempts. I did see 140, 137.32, 134. The copy actually went up by quite a bit from the timings. So latency, maybe 48 nanoseconds. We'll see. 48.6. Let's try to run it again. Okay, so 138.63, but I did see over 141s at this given memory frequency. But now the values are a lot more closer to each other, so 138.63, 137.31, 134.21 for the copy, and latency should be 48.5-ish. 48.5. So it is definitely alright. So and this did actually fail when I tried this very briefly at 8800. So it does fail as it does fail at, in Geekbench 3 as well. So from here, I think many of you are asking like how does this kit perform in daily type overclocking, like what kind of numbers could we run 24/7, as we can run even close to 8800 with 1.55 volts. I would assume we can do at least 8400 in HCI Memtest, but I think 8533, 8600 will be very hard or probably out of reach. So I would assume we can do at least 8400 and maybe even lower the voltage a little bit. Now when talking about the memory voltage for 24/7 operation, there are kits out there on the market. The high-end kits, they have default rated voltage of 1.45, so that's at least proven by the memory manufacturers that should be safe for 24/7 operation. I think 1.5 is still fine, but like 1.55 and afterwards like 1.6, that's too high to my liking for 24/7 operation. When I built that Z790 24/7 system for another Finnish user, I ended up using 1.53 on the VDD and 1.48 on the VDD-Q. So we can try like 1.5, but I think we cannot go higher than 8400. So let's see what happens. So I'll go back to the BIOS and I'll set 8400 and we can start at that value and just see how it performs in HCI Memtest. And okay, that's a pass run in HCI Memtest at DDR5 8400, but now with the same timings I used for the last test runs at 8600 to 8750. So this is actually pretty interesting. So very good overall timing table at DDR5 8400, and it's not only that, I also lowered the memory voltage from 1.55 to 1.5. So this is pretty much the best run I've been able to do in HCI Memtest this far. So let's open up all of the CPU-Z windows, etc. So the highest level where I've managed to get this far in HCI Memtest has been around 8000 to 8200, both with the Hynix screen OEM as well as with the G-Skill sticks I've tested this far. Like in the Z790 daily build video, when I built a Z790 daily system for another Finnish user, I used 8200, but CAS 36, and I think it was 4747 or 4848, etc. But with most of the sub timings, auto and memory voltage was 1.53 for VDD and 1.48 VDD-Q. So this is all around much better. All of the timings are manually set, but also lower VDD voltage. So let's open up. I still need to open up the motherboard pod. So here's the voltage table, and now we just need ELIDX1 for the sub timing. So only 5.2 and on the CPU, and here's the full timing table. So 34, 47, 42, 36. All of the sub timings are manually set, just like in the last test runs. So it's pretty okay if you ask me. So let's save a very quick screenshot. And the last thing what I want to do is run AIDA64 just to see the performance figures at this configuration. So like how good would it perform? But based on my own experience and thoughts, this is all around much better configuration than something like 8600, even 8800, with very basic main timings like 38, 52, 52, and TRAS at very high level like 108, just like the default value for this given memory kit, when all of the sub timings would be auto. So this is definitely much faster if you ask me. The latency figure in AIDA64 should be a lot better with this configuration compared to something like that. So let's quickly check that one as well. So AIDA64 and cache and memory benchmark. Now we can also see how do what it actually, so it actually changed the orientation. I don't know why, but memory 131.73, 129.67 write, copy is at 126.82, and latency I think it's like a bit over 50, as it was 48.5 ish during the last test runs, so it should be 50.9. So that's actually interesting. Why? Yeah, it doesn't matter. So I accidentally clicked the change order button, but yeah. So I actually passed this twice. I already filmed this part a bit earlier ago, but for some reason the video footage corrupted, so I couldn't save it. So this is another run. The actual result shouldn't vary that much. I should have the previous run over here as well. So 130 A8. So this run was actually a bit better all around, except that, yeah, it was actually a bit better all around. So it doesn't really matter. So the overall first-hand experience now with this given memory kit is extremely good. So I'm extremely happy about these results, considering this is the first time I try any like memory, especially high-end memory from Acer technically, although the actual branding is Predator Storage, but it's owned by Acer. So very good, and I think if I had a bit better CPU I could do a bit higher. I tried 8533 on the memory frequency, both with the actual multiplier as well as by raising the base clock with the 8400 multiplier, but it does crash at some point during the HCI Memtest. So I will call 8400 as the limit for this kit, but with good voltage of 1.5. Maybe it could go even a bit lower if I really tried it, I don't know. But 1.5 is definitely in the safe zone, if you ask me. As I already said during this video, many high-end memory kits have a default rated voltage of 1.45, so 1.5 isn't that high increase from that level. So I'm definitely sure you can use 1.5 safely for 24/7 operation, but I wouldn't use something like 1.6 and higher, because the memory does really heat up when you really stress it a lot, when a lot of the capacity is being used. But yeah, that's pretty much it. I didn't actually test the best G-Skill kit I've had this far, the one I used for the qualifier phase of the G-Skill competition. Maybe it could do, well, I'm sure it will do at least 8200, maybe 8400, but I doubt it will do this given configuration, at least with this low voltage. So this result is exceptionally good. I'm definitely happy about it. So what do you think? Would you consider buying some of these new memory kits from Predator Storage for your new system? Please give me a comment down below, like what do you think about these memories, and give this video a thumbs up if you like to see my first-hand experience with these new memories from Predator, and subscribe to my channel. Maybe check out my Patreon page as well if you want to support my work. But yeah, this is the first-hand experience with the Predator Hermes DDR5 6800 Cas32 memories featuring Hynix A-Die memory ICs. Hopefully you enjoyed the video, and thanks for watching one of my videos once again, and I will see you on the next one.